All right, so this week, as I mentioned, we will do statements. So by the end of the tutorial, you guys should be able to identify when an implication is true or false, and if it's vacuously true, prove a statement involving quantifiers, find the converse, contrapositive, and negation of the implication, and decide whether it's true or false. Check if the given statements are logically equivalent. So we'll have 3 different activities to cover those learning objectives. The first activity, which of the following statements are true? How would you prove it? So I'll give you 3 minutes to think about them and we'll take it up. Okay? Anyone has any question? If you have question, you can ask me right now. When is your test? Midterm. Is it next week? 29th. Is that next week or the week after? Probably the week after. Oh, it's next week. Oh. So it's next Thursday. Are you guys ready for it? Super scared. Next week. Yeah, it's the only midterm. So you'll have 4 quizzes and 1 midterm. And then exams. You have 3 tests on the same day? Oh my god. I guess for 102 you don't need to study that much. Since well, the first 2 chapters you were tested on them already, so just study the next 2 chapters. So chapter 3 and chapter 4, I guess. So is chapter 4 gonna be on the test or no? Actually, I don't even know what chapter 4 is. What's gonna be, do I know the average for the quiz 1? I do know, but I don't think they want me to tell you guys. So I don't want to comment on this. But I would say you guys did worse in quiz 2 than quiz 1. Okay, so quiz 1 was better, slightly better than quiz 2. The average, I'm talking about the average. So do you guys know if induction is gonna be on your test or no? You think so? Okay. Well, then I'm slightly worried since you guys said you haven't finished chapter 3 yet. And the quiz and the test is next week. So I would say it's up to 4.1. Oh, it's only 4.1. So it's just simple induction. No variation and stuff. Okay, then that's easier. Anyway, I think you should start to prepare for the test already if you didn't do on the first 2 quizzes. I don't think the test will be easier or harder. It should be on the same level of difficulty. Yeah. Anyway, let's do activity 1, part 1. For the first one, every natural number greater than -5 is greater than 1. Is this true or false? First statement, is this true or false? Guys, true or false? True. Okay, true. Why is it true? Yes, because they are natural numbers. Exactly. Okay? So, since natural numbers are always greater than 95, and natural numbers are always greater than 0, this is true. Okay? Number 2, if a natural number is greater than 95, then it is greater than 0. Is this true or false? Number 2. True. Okay, this is true as well. Number 3, again, for the same reason, okay? If then, so this is your P, this is your Q. Your P is true because a natural number is always greater than 95. Your Q is true as well since natural number are always greater than 0, so it's true. Number 3, is this true or false? Number 3? 3? Okay, one of you think it's false. Okay. Yes, it's vacuously true. Okay, the reason is that, again, here, this is your P, this is your Q. Okay, so let's look at P first. A natural number is less than 85. This is obviously false. Okay, so your P is false. If your P is false, then the whole statement is true. So this is vacuously true because your P is false. Number 4, is it true or false? Yes, vacuously true again. Okay, for the same reason, except number 4 is like number 3 written in logic symbols. So number 3 is number 4 written in English, and number 4 is number 3 written in logic symbols. So they're the same thing. So for the same reason, it's vacuously true. Part 2, we have P is greater than 2, R is x is greater than or equal to x plus y. Is the following true or false? Prove the true statements. So let's look at the first one, this one. For all y in real number, for all x in real number, R, so let's write down R here, x is greater than or equal to x plus y implies that 2 minus y over 2 is greater than or equal to 1. Is this true or false? Vacuously true. No. No. False. No. It can't be both. It is true, but it's not vacuously true, okay? It's true. Basically, this is telling you that your x and y are real number. So you need to decide if this implied this is true. So we have x is greater than or equal to x plus y. You can minus x on both sides, so you'll get y is less than or equal to 0. So basically, it's asking you if y is less than or equal to 0, y is a real number. Can you get 2 minus y over 2 is greater than or equal to 1? So it becomes an inequality question. Y is less than or equal to 0, which means negative y is greater than or equal to 0. And then you add 2 on both sides. And then you divide by 2 on both sides. Okay, so this is true. Number 2, for all y in natural number, there exists x in natural number such that p implies r. So again, p, let's write it here. 2, for all y in natural number, there exists x in natural number such that y is greater than 2 implies that x is greater than or equal to x plus y. Alright, so is this true or false? How did I get y is less than or equal to 0? You minus x on both sides. Okay, or you move x to the other side. You move it to the other side, then you'll get x minus x, which is 0, greater than or equal to y. Does that make sense? Okay, number 2. Guys, number 2. True or false? Don't guess, guys, don't guess. If you think it's true, okay, you need to find such x. If you think it's true, then you pick any y that's greater than 2, then you need to find your x such that this is true. Okay, if you think it's true. So try that. Pick any y. So let's say pick y equals to 3. What do you have? Okay, so this is false. You'll see that no matter which y you have, you can never find such x in natural number such that this is true. Okay? Yeah, it's false. It's false. So there does not exist such x from pick any y in natural number. There is no such. Actually, pick any y in natural number and y is greater than 2. there is no such natural x such that x is greater than or equal to x plus y. Number 3, we have for all y in natural number, there exists x in natural number such that y is greater than. Actually, this is unnecessary. Okay, since we don't even have x here. So for all y in natural number, y is greater than 2 implies that for all y in natural number, there exists x in natural number such that x is greater than or equal to x plus y. Is this true or false? No, they are not the same. 2 and 3 are not the same. That's why we gave you this question. It's a common mistake. For number 2, the whole thing is a mathematical statement. Okay? For number 3, this is a mathematical statement and this is a mathematical statement. True or false? Okay, this is vacuously true. Why is that? This is your P. This is your Q. So you need to decide if your P is true or first. For all y in natural number, y is greater than 2. Is this true or false? Okay, this is false. This is false. So since your implication is false, which makes the whole statement true. So this is vacuously true. Okay, those two are really important. Please make sure you understand them, because this is a common mistake. So either P is false or Q is true or false. No. Are you saying that to make the whole statement true, that's the only cases? If that's what you meant, then yes. Okay, then yes. So recall the table. Let me just draw the table here. You have P, you have Q, true, false, true, false. And let's have P implies Q. Okay, so true implies true is true, true implies false is false, and then when the implication itself is false, you get true. Okay. Anyway, activity 2. They are given a statement here, and they ask you to find the contrapositive, converse, and the negation of the statement. So let's review this part a little bit first. If we have P implies Q, what is the contrapositive of it? P and not Q. No. Contrapositive, not negation. it's not Q implies not P. This is really, really, really important. Please make sure you know this, okay? It's not Q implies not P. Okay, so what's the converse of this? Converse? Anyone know what's the converse of the statement? No. Converse is just switching the position of P and Q. So converse is Q implies P. Okay? What about negation? What's a negation of the statement? Negation. Negation, guys, negation. The negation is P and not Q. Okay? Anyway, so that's what I was gonna say. Give you some time to write those three statements, contrapositive, converse, and negation of the statement, and then we'll take it up. Okay, let's look at the first one. What is the contrapositive of this statement? So recall that contrapositive is not Q implies not P. So we have for all A in natural number, for all B in integer, and we have not Q. This is our Q. Okay, so we need to negate this whole thing, which will give us A greater than or equal to B, and A plus B is not natural number, implies not P, so that's A squared minus B squared is less than or equal to 0. That's your contrapositive. Converse is just switching them around, so this should be easy. Okay, so let's see. Converse negation is slightly complicated because for negation you need to negate the quantifiers as well. So you need to negate those two. So what is a negation of for all? There exists. Okay, Andrew said so all does not become every in contrapositive, but it does in negation. Yes, you don't need to change the quantifier for contrapositive. There exists A in natural number. There exists B in integer such that, okay, so you need to negate this. Recall that negation of P implies Q is P and not Q. So P and not Q. Okay, so not Q is A greater than or equal to B, and A plus B is not natural number. So that's a negation. Any question? Question? What's the negation of there is no X in? What do you think? So just think about, actually a lot of the time when you think about it in English, it actually makes sense. So you don't really need to use logic symbols. So there, let's say there is no, let's make it a real statement. There is, okay, let's say this. There is no student in MAT102 who got perfect on quiz 2. That's not true, but I think that might be true. I didn't check. So let's say there is no student in 102 who got perfect on quiz 2. What's the negation of that? So let's write it down. There is no student in Math 102 who got 100 on quiz 2. So how do you negate this? There is a person with infinite IQ. So think about this, okay? So this is saying we don't have any student who got 100. So then the opposite of that means there is a student who got 100, right? So that means there exists a student. There exists a student got a perfect on quiz 2. Actually, let me see if the statement is true. Might be true. Give me, okay, you guys think about part 2 and let's see if the statement I just created is true. version A, oh, not true. Version A has 2 students got perfect, and version B has 5 students got perfect. So this is a false statement. This is a false statement, and this is a true statement. Okay, number 2, which of the above are true? Original versus contrapositive versus negation. So which one is true? No. You cannot prove a statement using converse. No. The converse and the original statement, the truth value of that, they don't affect each other. So this is just like, think about, you have P implies Q. If you have P implies Q, you know if it's true or false. Does that tell you any information about Q implies P? Okay, so even if you know if this is true, you don't know if this is true. Okay, it's like, if both are true, then it becomes an if and only if statement, but the truth value of those two statements, they don't affect each other. They are independent. Anyway, yes, you can prove using contrapositive, and you can use negation as well. Yeah. Anyone know which one are true? Okay, the original statement. So those two, the original statement and contrapositive are true. So since we mentioned this, I'll do a short review, okay? So a few things. If we have P implies Q, you should know this is logically equivalent to its contrapositive. So if you can't prove this, but you can prove this, then go ahead. So this is one of the proving technique. Instead of proving this, you prove this. Since they are logically equivalent, if this is true, then this is true. The other thing is you should know that if the original statement is true, then the negation is false. If the negation is true, then the original statement is false. But back to this question, the original and contrapositive are true. Okay? But just by knowing this, without looking back to the converse, okay, without looking at this, just by giving this, do we know if the converse is true or false? No, we don't. Okay, I just mentioned it. I just mentioned that before, so we cannot know. We cannot know if the converse is true or false. Okay, move on. Activity 3. So they want you to write the truth table and find if the statements are logically equivalent. Try this. Oh, okay. So here, write it in red. Actually, let's just write it in this way. P and negation of P. So if this is true, then this is false. If this is false, then this is true. Okay? That's all I wanted to mention. So if you can decide your P is true or false, if you can decide if your negation is true or false, so you can. So sometimes it's really hard to decide if this is true, but if you take the negation of that, sometimes it's easier to decide if it's true or false. Okay? So it's another proving technique which is called contradiction. Anyway, truth table. Do it yourself, but I'll write down my truth table as well. Just don't look at mine, okay? Oops, this is P, not P. Alright, so I made a truth table here. When you do a truth table, please write it in this order. So to make my life easier, please P true false false and Q use true false. Okay, so that it's much easier for me to check your answer for your assignments. Anyway, negation of true is false, false, true, true, and false, true, false, true. Okay, now we have not Q implies P. So you check those two columns. Okay, so false implies true is what? What's false implies true? True, okay? True. True implies true is true. False implies false is true. True implies false is false. Now you have not P, which is this column, if and only if this column. Okay, so let's look at that. False if and only if true would give us what? False if and only if true would give us what? Is it frozen? I don't think it's frozen. Okay, again. Okay, false, exactly. Alright. False if and only if true. Again, that's false. True if and only if true is true. True if and only false is false. Now let's look at negation P and negation Q. So look at those two columns. False if and only if false is what? What's false if and only if false? True, okay. False if and only if true is false, false, true. Now lastly, we have this implies this. So true implies true is true, false implies true is true, false implies false is true, true implies false is false. All right, so now let's compare those two columns. Are they logically equivalent? Are they logically equivalent, guys? No, okay, they are not logically equivalent. Not logically equivalent. All right, and the last question is gonna take a long time, so I'll give you the answer, but we'll not do it in tutorial. So go home and do it yourself. Just write truth table, okay? This is logically equivalent to this. I circled it, this one, okay? This is a correct one. Check your answer is the truth table. Before we end the tutorial, I do want to talk a little bit about if and only if one, okay? Because I don't want you to memorize everything. So let's talk about this somewhere here. Okay, let's write it here. If we have P, if and only if Q, and you don't remember the table for this, but you do remember what P implies Q. Well, P if and only if Q is the same as P implies Q and Q implies P. I know that you know the truth table for this, and you know the truth table for something and something, okay? So, for example, when we have false if and only false, why is it true? This is the same as false implies false and false implies false. This will be true. This will be true as well. So true and true would give you true. Same idea for false implies true. Why is it false? False if and only if true is the same as false implies true and true implies false. This would give you true, but this would give you false. Then true and false would give you false. Okay, does that make sense? Okay, if no question, you guys can leave. That's the end of the tutorial. I finished everything. Go home, not go home, stay at home. Stay safe and try this question. Try the extra practice. Okay, I will upload the recording tonight, and I will upload the recording of the activities we left from 2 weeks ago tonight as well. Okay, bye guys. Stay safe.